There's multiple ways to sketch a parabola. One of those ways is to sketch a graph that is already in turning point form. So in the next video we'll look at a graph that's in standard form, but one reason why we like a graph in turning point form is because there's a few things already that we can determine from it, from the formula a equals so y equals a brackets x minus h plus k. There's a few things that we can determine from this already, and the fact that we've already got turning point, we have one piece of information that's already solved. So if you recognize with the parabola, parabolas actually need 3 points to be joined up. So you need one, any random point, you need the turning point, and you need some other point so that you can join those 3 lines up so that it can create a curve. So to sketch an equation that's already in turning point form, as you can see on the right hand side, that's turning point form. I've put down 7 steps. 7 steps will vary with everyone else, but these are the 7 steps that I prefer to use with my class. So first step is you need to ensure that the equation is in turning point form. So let me give you an example. If you had an equation that said y equals x squared plus 2x plus 1, that is not in turning point form. So therefore we can't use this particular set of instructions for turning point form method. However, if you had something like y equals brackets 2 x plus 1 squared plus 2, this is in turning point form because this is similar to that. We can then use this method to sketch the graph. Now question 2, so we've done question 1. Question 2, what is the nature of the turning point? So what I mean by nature is that there are 2 particular cases that we can have with a parabola. We can have a parabola that is positive, or we can have a parabola that is negative. So when it's asking for the nature of the turning point, is it a minimum or is it a maximum? As well, just looking at the equation of the turning point form, we can determine what the turning point already is. So you can knock another bird down with that stone and say, okay, I'm going to, determine what the turning point is, or what this turning point is right here. So we'll look at this in an example later on. Find the y-intercept is the next step. So again, with linear equations, finding the y-intercept, we have to substitute x equals 0 into that equation, and we get a value for y equals, then we set coordinates as 0, and whatever value you get for the y coordinates there. So the next one is find the x-intercepts. That should be x-intercepts because sometimes you'll come across with 2 and sometimes you'll come up with 1, sometimes you'll come up with nothing. So the answer you should get for this one is x equals whatever your answer is, comma 0. And this one you'll come up with another answer and you'll get comma 0. Next step, plot all the points and join. So let's just say, for example, your x-intercept is here, your x-intercept is here, but your turning point, let's just say, is up here. What we would do is we'd plot those 3 points and then join the line to make a parabola. And when we're talking about the domain, we're talking about the possible values in the x direction. And when we're talking about the range, we're talking about the possible values in the y direction. So this will make a bit more sense once we look at the example. So first question is, sketch the graph of y equals x squared plus 2x minus 5. So you can tell already by the first question, ensure the equation is in turning point form. The equation is actually not in turning point form at the moment. So to get an equation into turning point form, what we need to do is actually complete the square. So 1, complete the square. So when we're completing the square, this goes back from the previous video, so I'm going to do this a bit faster than usual. Y equals x squared plus 2x plus 1 squared minus 1 squared minus 5, and so we get y equals x plus 1 squared. So x plus 1 squared minus 6. If you haven't watched the video on completing the square, please familiarize yourself with this first, as I did jump quite fast with this one. So, question 2. Question 2 says, what is the nature of this turning point? So the nature of this turning point is determined by the number in front of, or the dilation factor, or the sign of the dilation factor. So in this case, the dilation factor is just 1. So since the dilation factor is 1, what we can say is that the graph is going to be a positive parabola. So since A is positive, the graph will be looking like this. So the graph will be a U shape. Now, the next thing I would recommend you do is find out what the coordinates of this turning point are. So what is the turning point of this graph? We already realized that we can determine the turning point straight from looking at this. So to find the turning point of this graph, we just go, what is the h value? The h value is 1, but whenever we take the turning point, we take the negative, or we flip the sign, so it's going to be -1, -6. So in this case, the turning point will be -1, -6. Step 3. Step 3 says, find the y-intercept. So to find the y-intercept, what we need to do is let x equal 0. So what we're going to do is we're going to go, alright, sorry, to find the y-intercept, let x equal 0. So we get y equals, so we're going to use the formula x plus 1 squared minus 6. So we let x equal 0. And if we let x equal 0, what we end up getting is, you can see y equals 0 plus 1 squared minus 6. And from here, we just solve y equals 1 squared minus 6, y equals minus 5. So therefore, the coordinates of our y-intercept are 0, minus 5. If you're wondering where I got the 0 from, well, I had to substitute x equals 0 in. So that was kind of the placeholder already that we had there. Next step. Next step says, find the x-intercepts. So when we want to find the x-intercepts, we need to let y equal 0. So let's do that with the next step. So I'm just going to move this down here. So question 4. To find the y-intercept, let's rewrite our equation again. So our equation is y equals x plus 1 squared minus 6. So we need to find what the solutions are when let y equal 0. So if we let y equal 0, what ends up happening is we substitute 0 into here, and this becomes x plus 1 squared minus 6. So from this step, we need to rearrange so that we can get x by itself. So this becomes 6 equals x plus 1 squared. Now we need to transpose again. So keep in mind that the opposite of a square is a square root. So the inverse operation of square is square root. So we're going to take the square root of 6, and we're going to equal that with x plus 1. There's a really vital thing that you need to remember with this case is that whenever you take a square root, we always come up with two components, the plus component and the minus component. So you need to always make sure that you put the plus minus in front of the square root whenever you're taking a square root of a number, in this case. So from here, we're not finished yet. We get, just so that everyone can stick with the same idea, we get plus minus root 6 minus 1. Or, in this case, we get minus 1 plus root 6 and minus 1 minus root 6. So our two intercepts will be at minus 1 plus root 6, comma 0, and minus 1 minus root 6, comma 0. So you can see here that we've got actually 4 points. We've got 1 point up here to, oops, sorry. We've got 1 point right here, which is our turning point. We've got another point, which is our Y-intercept. We've got another point right here, which is our X-intercept, and another point right here, which is our X-intercept. Some of you may be wondering, well, what are the values of minus 1 plus root 6? You literally type that into the calculator, and they should roughly equal the following. I'm just going to type these into the calculator and come up with values. And the values that you get when you type them into the calculator are minus 3.45 and 1.45. So let's plot all these points onto the calculator. Sorry, I meant graph. So let's start off with the x-intercepts. So the x-intercepts is the first one is at 1.45. So 1.45 lies roughly there. The next one is minus 3.45, so it lies roughly there. And let's look at the other points that we have. We have minus 1, minus 6. So I'm going to draw that as my turning point, minus 1, minus 6, right there. And we don't need this last point because remember, as with parabolas, we only need 3 points to plot the graph. However, I'm just going to put in 0, minus 5, just because we calculated it, which is right there. So if we join up all these points, what the graph should look like is something that looks like this. Hopefully, crossing my fingers for a good, accurate graph. Okay, that's the best I can do at this stage. Make sure you label these points as such. So this is minus that, this is that, and this point right here is your turning point, which is minus 1, minus 6.